Number 4 says a skier leaves the horizontal end of a ramp with a velocity of 25 meters per second and lands 70 meters from the base of the ramp. How high is the end of the ramp from the ground? Okay, so let's begin by labeling our diagram. So if you have a skier here that's sliding downhill, eventually he's going to reach the end of this ramp here, and he's going to be launched into midair. So his motion is going to look something like this from the moment that he's launched to just before it hits the ground here. Okay. Now, we are told in the problem the distance in the x direction that the skier traveled. So the distance from here, from here to here is approximately 70 meters. So that's our distance in the x direction, 70 meters. We are also told the initial velocity of the skier. From the moment this skier was launched from this ramp, right at this point here, its initial velocity in the x direction was 25 meters per second. Okay. And ultimately, what we're trying to find here, we are trying to find the height of the ramp. In other words, we are trying to find what is the distance, this distance here in the y direction, the skier traveled. That's ultimately what we're looking for. The distance in the y direction from here to here. So let's put a question mark there to show that's what we're trying to find. What is the height of the ramp? In other words, the distance in the y direction. By the way, before we begin working out this problem mathematically, let me go ahead and label the initial velocity in the y direction. So remember, just like before, the moment this skier was released from this ramp here, at that brief moment in time, the initial velocity in the y direction was just 0 for that instantaneous moment in time. And of course, because of gravity, he began to speed up or accelerate until he reached the bottom. But the initial velocity was 0 meters per second. So keep that in mind as we're working out this problem here. And we're looking for the distance in y, or the height of the ramp. Okay, so just like before, we're going to use our displacement equation to solve for this problem here. But we're going to do something slightly different here. Because we're trying to find the displacement in y, that means we're going to start with looking at our x equation first and determine what's happening in the x direction. So ultimately, since we want to find the distance in y, we need to begin by finding the time in free fall in x. So that's where we want to start, the time in free fall in x. So let's begin with writing out what is our equation for the x direction. So the displacement equation, we know, is just initial velocity times time plus 1/2 multiplied by acceleration multiplied by t squared. Now, let's plug in what we know. What is the acceleration in the x direction? We know that because there are no forces acting here in the x direction. Remember, gravity only acts in y, and we're ignoring air resistance. Since there's no forces acting in the x direction, that means the acceleration is always 0 for these problems here, because we're moving at a constant velocity. So if I plug in an acceleration of 0 into this equation, this part of the equation goes away, and this reduces to initial velocity. This distance is equal to initial velocity times time. Okay. Now, let us plug in what we know. We're given the distance traveled in the x direction, it was 70 meters, and we're also given the initial velocity in the y direction. I'm sorry, the initial velocity in the x direction was 25 meters per second. So let's plug those in. So the initial velocity is 25. The distance in x is 70. Now we want to solve for t. We want to get t by itself. How do we solve for t? Well, it's easy. All we need to do is just divide, because we're solving for the time in free fall. So divide that by 25, that goes away. Whatever we do to one side, we have to do to the other. So 70 divided by 25. Turns out when you put in your calculator, you get a time in free fall of 2.8 seconds. Okay. So that's the first thing we do, solve for the time in free fall. And remember, thinking logically here, if the skier spends 2.8 seconds in the air in the x direction, obviously that's how long he spends in the air in the y direction. So now let's go back to looking at our vertical component here. So we know the time in free fall was 2.8 seconds. Okay. So now let us use this information to plug into our displacement equation, because ultimately that's what we're trying to find. We're trying to find the displacement in y. So let's write our displacement equation, because we know it. 1/2 at squared. Okay. Now the question is, what is the initial velocity in the y direction? Remember, we just said it, that the moment the skier left the ramp, for that brief moment in time, its initial velocity was 0. So let's plug in 0 into this equation. When you plug in an initial velocity of 0, remember 0 times some number is just 0, so that part of the equation goes away. And so our displacement equation for the y direction just reduces to this, 1/2 at squared. Okay. So how far did the skier travel in the y direction? In other words, how high is the ramp? It's easy. Okay. All we need to do is plug in the acceleration of gravity in the y direction, and we know that the acceleration is 9.8. Okay. We solve for the time, we plug in the time in free fall, and we know that as well, as we solve for that before this. The time in free fall that we solved for was 2.8 seconds. Of course, we're going to square that. Okay. And when you put that in your calculator, 1/2 times 9.8 times 2.8 squared, your displacement in the y direction is going to be 38.42 meters. And that is your final answers. So that's the height of the ramp. In other words, that's how far he traveled in the y direction. So let's go ahead and plug that in here. So this distance here, so the distance in the y direction here is 38.42 meters. And that is our final answer. Okay. And that is the fourth one.